Welcome from my side as well. Super awesome to see more than 170 people joining this session and having interest in the topic. I would like to quickly introduce myself. So my name is Michael or Michael, however you prefer. I am an infrastructure consultant with ThoughtWorks now since October last year. And if I'm not working, I'm mainly father of a little boy and a little girl. And we live in Stuttgart in the south of Germany. And besides coding and children, I enjoy cycling a lot, play the guitar from time to time. And if I find some time, I do a lot of ranting on Twitter as well. So what will it be tonight? Short agenda. First of all, I would like to give you a little context of the project I'm currently working in and how this relates to our topic. I also want to motivate why you should consider running Terraform in pipelines. And therefore, we will go through a little introduction to Terraform, talk about blast radius and nuking infrastructure, and also, of course, talk about what you have to maybe consider if you run Terraform in pipelines. And then we will sum up and give a little outlook. As Jenna just mentioned, if you have questions, feel free to write them in the chat anytime. We'd rather use the questions or take the questions in the written form. So please mute yourself all the time. And we will have a short block of questions like every 10 minutes, and I will try to answer them as good as possible. And if there are any questions left, we have time at the end of the presentation to talk about them. One assumption I have is that you all have at least experience with infrastructure as code and hopefully some experience with Terraform. Since this talk will not be an introduction to Terraform, it is more about how to bring your Terraform code into pipelines. And maybe also a little bit how to test it and how to structure it. But I assume you all have at least beginner level knowledge of Terraform. So what was my journey into Terraform? As I mentioned, I joined ThoughtWorks in October 2019. Before, I worked 3 years in a company who had mainly on-prem infrastructure, or at least my team only worked with on-prem infrastructure. So ever since October last year, I'm quickly catching up on all those fancy cloud topics and automation tools. And we are using Azure in our project. So not only the Azure Cloud Platform, but also Azure DevOps and Azure DevOps Pipelines. And beginning December last year, I think it was the first time when I really got in contact with Terraform a lot. So I used it a little bit before. I knew how it basically worked. I attended some meetups, but I never worked with it in a production context. And roughly at the same time when I learned how to use Terraform and what you can do with it, we also had a big team scaling. So our team grew from around 30 people to about 60 people. And that also involved that our infrastructure grew a lot because we had more services than before, and more services needed more infrastructure. And in the middle of this scaling, we had a big infrastructure outage, which basically means that all the infrastructure was gone from one day to the other. And we started to think about what we could possibly do that this doesn't happen again. And the talk is mainly arranged around our thoughts and ideas how to prevent such an outage in the future and how to make it better. And one outcome of this was that we started to work with Terraform in pipelines. This was about 2 months ago, and today is the meetup, and I hope you can all learn something from our experience, and I'm happy to discuss questions and ideas around that with you. So I thought that when we start talking about Terraform, it's maybe good to do a short recap on what infrastructure as code is. So most of you might be familiar with developing applications and know how to write code, and maybe also know about the tooling that we nowadays have around this, which is like versioning your code in Git, using pipelines to build, test, and deploy your code, having tests in place, and all the workflows that you use in a team to collaboratively develop your applications. I think the main idea of infrastructure as code is to bring the very same familiar tooling and workflows to the infrastructure world. So if you made the same experience in the past as I did, a few years ago, infrastructure was mainly the topic of some people in rooms that were well hidden from you, and sometimes didn't want to get disturbed with their work, and they did magic things in black little boxes, and whenever you wanted to change, it was kind of a discussion because they didn't want to change their systems because they were running quite well, so why change them? And the infrastructure work was mainly sending Jira tickets and emails around, and it was not that pleasant. So one important idea of infrastructure as code is to bring the workflow that developers know from application development to the infrastructure world. This mainly means you want to describe your infrastructure in a piece of code, most likely a declarative description of how your infrastructure should look like. You can then add this code to a source code repository like Git. This then triggers a pipeline that builds, tests your code, and at the end, hopefully deploys your code. Therefore, it uses infrastructure as code tool like Terraform, and this tool manages an API of your cloud provider like Azure, AWS, or Google Cloud Platform. So the goal would be to bring this workflow to your infrastructure maintenance, and you want to work with the infrastructure the same way as you work with your application code. This being said, we can maybe start with a high-level overview of what Terraform is and what building blocks it has. So the main thing in Terraform is a command line tool called Terraform, and it gives you some commands that we will see later on to actually manage your infrastructure. Therefore, you write scripts in a language that's called HCL, and these scripts describe resources. I use these geometric figures to kind of draw them. And those resources are then used by providers to bring them alive on the cloud platform. So Terraform itself cannot be used to manage multiple platforms at the time. And Terraform, the basic Terraform binary doesn't know anything about Azure or AWS or Google Cloud Platform. Therefore, you need providers, and they kind of translate whatever you describe in your resources into commands that can then be applied to the API of the cloud providers. There are, I think, about 160 providers nowadays, so you can manage all major cloud provider resources, but also smaller providers like Heroku or DigitalOcean. And you can also manage Kubernetes, for example, with Terraform using different providers. And the last piece of, or the last building block that you need to know is the so-called Terraform state. Terraform state allows us to manage resources in mixed scenario. So you can use Terraform in a scenario where some of the resources are managed with Terraform and other resources are managed manually. This doesn't mean that you should do that, but you can do it. And it's also used to keep the state remotely and enable multiple people in a team to work together on your infrastructure code. I will come back to this 2 slides later and explain it in a little more detail. But maybe now we can dig into the Terraform workflow and see how we can work with Terraform. So after you wrote your code in this Hashicorp HCL language, you first of all have to initialize your Terraform environment. When you initialize the environment, it will download all required providers from the internet. And also the backend will be initialized where you store the state. And afterwards, you are good to go. The second command you use is the Terraform plan. And Terraform plan will compare the state that you have on the cloud provider with the expected state in your scripts. and will figure out what changes to make, but does not yet apply any changes. So it gives you kind of a checklist that you should carefully watch or check before you run the last command, which is Terraform apply, because Terraform apply will then create, update, or delete resources. And those resources that are deleted are finally gone. So it's good practice to check the plan before you apply it. And the last thing that the apply command then does is to update the state. The outcome of the apply command should be that the expected state of your infrastructure matches the actual state, or the other way around. Whatever you have in your scripts should then be in place on your cloud provider. So to get a better understanding of what this state does, I tried to draw a little picture. So let's assume you have, can I point here? How does this work here? So let's assume you have a subscription or account on your cloud provider where one or more resources are currently managed manually, and you want to start with Terraform. So what you do is you create a new Terraform script where you describe, for example, 4 resources. And initially, of course, your state file is empty because you did not run Terraform yet. So when you apply those resources to the cloud provider, Terraform will, of course, create those resources in the cloud. And the state will keep track of which resources were created. So you can now see there is one resource that has been there before. It's not managed by our Terraform script. So it's also not stored in the state. And when you later on remove a resource from your script, Terraform can kind of calculate the difference between the script and the state, and can see that this one resource that you removed from your script needs to be deleted, but not the resource that had been in place before. So once you apply this, the deleted resource will be gone from the script, of course, and from the state, also from the cloud, but still the manually managed resource is still in place. So I hope that gives a good impression of what the state is doing on a high level. There are some other details to it. The state file is a simple JSON file, but although people tend to do it, it's best practice to never ever touch or edit the state file manually. It had already disastrous effects, so take it as a warning. Do not touch, manipulate, or change the state file without the Terraform tooling. Okay, since that would be the introduction to Terraform, I think it's a good time to answer questions if there are any in the chat so far.
They kind of get answered by other attendees.
Super cool.
I will just bring it up. Maybe you want to add something. Will you be doomed if state gets somehow lost? Can you recover from a state loss?
I think you could do it with a lot of hacking, but usually I would say you are kind of doomed.
Okay. You can actually recover resources. You can import your resources to your state. There's a new piece of Terraform functionality called import, which will let you fix that problem, but it is not easy.
That's what I meant, yeah. So it is possible, but it's not a nice task.
Okay.
You want to prevent that.
Another question was, does Terraform give a graphical representation of the infra getting created, like, for example, CloudFormation Designer provides?
I'm not aware of such a tool, but I'm sure there are projects on the internet that help you doing that.
Okay.
Tim, do you know a tool who does this, or which does this?
I missed the start of the question, sorry.
Is there any tool that draws pictures of your Terraform infrastructure or diagrams?
There's the only one I know of is Terraform Graph, which will draw you the graphical relationship of your Terraform objects, not necessarily your infrastructure.
Okay, thanks, Tim. And what happens if resources were changed outside Terraform?
Terraform will make them match what you have defined in your code.
Cool.
Yeah, and this sometimes means that they get destroyed and recreated depending on whether there is a way to update or change them or not.
There's a follow-up question from Björn. What if your state loss happens because a state apply failed and you have an intermediate state?
I'm not sure whether I get that.
Your state is potentially in your pipeline or on your local system, and it's out of sync with your remote. If that happens, you keep all the pieces and reassemble them carefully.
Mm-hmm. I think linked to that was somebody was asking, do you persist the state then?
Yes.
Yes.
You do that.
Yeah.
Maybe I jumped over this a little too quickly, but there is a concept that is called remote state, and it allows you to store the state file, for example, in an S3 bucket or in a storage account on Azure. So there are different backends that enable you to store the state and also to lock the state during a Terraform run so that concurrent runs don't interfere in a bad way. I hope this answers the question.
Yeah. Björn asked if a state apply fails because AWS rejects the request. What do you do?
That was the question I was answering.
Oh, okay, cool.
Keep all the pieces, reassemble them carefully.
Okay. Maybe we can have like one last question. On which service does Terraform run on? I don't know if you mentioned that in your talk, actually.
It basically runs on any machine that can run the Go binary.
Okay.
So you can run it on a laptop, you can run it on a Linux machine, you can run it on a server, or you can run it in your CI/CD tool.
Okay, cool.
You can also run it in a Docker container.
Okay. Is there a possibility to snapshot TF state in a storage account?
Yes.
Yes.
Okay, cool.
Absolutely. Yeah.
Okay. There are some more questions, but maybe do you want to answer them later?
I'll do what I can to answer them in chat as well. Michael,
cool.
Thank you, Tim. So cool.
Amazing.
Okay, so that being said, we can maybe take a look at some challenges that come up with infrastructure as code. So I mentioned before that the idea is to provide the developers the same workflow they know from application development and the familiar tooling. But there are some differences that might make it a little more challenging to manage your infrastructure code in comparison to your applications. So we assume that using a continuous integration or continuous delivery pipeline for application development is kind of standard today, and that you are familiar with the concept of a basic build pipeline. So when you look at a build pipeline for an application, you usually have a lot of safety nets to make sure that no bugs or no problems make it to production. So for example, you might have a comprehensive test suite for your code that follows the idea of the testing pyramid with some unit tests on a small level with some functional tests and maybe some end-to-end tests. And all this should assure that when the application version has passed the pipeline, you can be confident that it will work as expected in production. When you use immutable deployments like containers, you can also use methods like rolling updates with multiple instances running, depending on whether your application is stateless or not. But for stateless applications, I would say it's pretty much this topic is done. Yeah, you can safely deploy new versions in a fully automated manner and know quite well that things work. And if you have an outage, it's a very short one because you can just replace it with an older version. With infrastructure code, things are slightly different. So first of all, we have a lot of stateful resources in infrastructure. So for example, the database is definitely a stateful resource. If you lose it, you at least have to apply some backups or a recovery strategy, and you will have a longer lasting outage than redeploying a Docker container. That is one thing. The other thing is that we have not as good test tools nowadays that we have for our applications in the infrastructure world. So I would say the infrastructure community is quickly catching up on that, but testing infrastructure is much harder already from a tool side. You don't have the nice toolings, I don't know, IDE integration, mocks, all this. It's not there in the infrastructure. And also testing infrastructure can be quite expensive from a time perspective. It takes quite a lot of time to provision certain infrastructure, see whether it works, tear it down again, and then go on in the pipeline. And it can also be expensive from a money perspective, because you run a lot of resources in the cloud. So for bigger projects, that might not be an issue, but for smaller projects, you want to watch your costs, and this can become a factor. Another thing that adds to this problem is that we don't usually have immutable deployments of infrastructure. So this means we do not start our deployments from scratch, but we have certain pieces of infrastructure in place, at least in a production environment, and we apply only changes to something that already exists. And this is something that is much harder to predict in a dev environment, because dev and prod will differ in certain aspects, and you cannot be 100% sure that something that worked in dev will also work in prod. I think I also already mentioned the long feedback cycles that add to this problem, but overall, I would say it's still more challenging to automate deployment or provisioning of infrastructure compared to application development and application delivery. So this being said, I think it's important to become familiar with one interesting term that I only learned after our outage, which is the so-called blast radius. I give you a little time to read this quote. So mainly, I think blast radius describes the maximum negative impact Terraform run can have on the infrastructure when things go really wrong. And before you go into automating this and potentially automating such a disaster, you might check the opportunities or the adaptations you have to make to your infrastructure code to reduce this blast radius. As I said before, we learned it the hard way. We had a complete outage. And after this outage, we do what we always do after a big problem happened. We did the so-called post-mortem and basically ask ourselves 3 questions. So we asked, why did this happen? The concept of the 5 whys can help you here to really come to the root cause of the problem. We asked ourselves the question, what did we miss? And finally, we asked ourselves the question, what can we do to prevent something like this from ever happening again? It's very important that you do this in a blame-free way. So it's not interesting who did the mistake and what this person did wrong. It's important to learn from that, and you should set up a stage where it's easy for people to talk about this and not run into the issue of finger pointing and blaming each other for doing things wrong. So I would say our post-mortem worked quite well. And as an outcome, we had a bunch of ideas what we could do to prevent us from further infrastructure outages. And I think here we come to the core of this presentation, because up to this point, our Terraform workflow was someone checking out the infrastructure repository on his or her machine, making changes to the code, and then applying it from the laptop. And for example, it sometimes happened that people forgot to commit their changes. So whenever someone else started to work with the repository, there were changes in the infrastructure that were not reflected in the code repository. So one important thing for us was, for example, to run this in the pipeline for the sole purpose of avoiding such issues. Until this infrastructure outage, we also didn't have any staging environments. This means we only had one environment, and we kind of tested all our changes in production. So all changes to the code directly made it to the only environment we had, which of course was nothing you want to have if changes have such effects. So we decided we want to have staging. We also decided to introduce more testing, because until this point we didn't have any tests in place. We talked about optimization for mean time to recovery. This means how can we reduce the time required to bring the infrastructure back up once we have a complete outage or everything is gone. We also considered going for immutable infrastructure if possible. We thought about the idea of locking stateful resources. This means that you block them from being accidentally deleted. We wanted to modularize our Terraform code so that the teams who change it are more familiar with their resources and maybe have a better understanding of their changes and the impact. And we wanted to split state so that if state gets corrupted or something happens to the state, it has less impact than everything is gone. Backup and recovery is also something you want to have in place here, because you need to come back with a database, for example, if it got deleted. And we also wanted to reduce privileges for our pipelines as much as possible. So that was kind of our brainstorming around this and all the ideas we had. And I would like to show you now which of those ideas we implemented and how we did that. So as I mentioned, the first thing we considered was having a staging in place. I already told you that before the outage, we only had one stage. You can now call it dev or prod or whatever. It doesn't matter, because if it's gone, everything is gone. The idea was that we have 3 stages for our platform that we built. The 3 stages were mainly, we mainly agreed upon the 3 stages because we had to be compatible with a third-party application that also used 3 stages. For us, it was important to have a development or testing stage. The other 2 stages are mainly identical for us. And underneath those 3 stages, we have so-called shared infrastructure. And there we had all the resources, or have all the resources that are used in common by the stages. So for example, a container registry where you have a Docker image that gets deployed to one stage after the other will be stored in such a shared resources, in such a shared environment, or also certain blobs or binaries that we use in all environments. And the last example is a key vault. So that was the first measure. We split up into multiple stages and agreed that infrastructure code will be promoted from dev to prod with a test on dev before it gets promoted to production. The second measure we took was modularizing our Terraform code. So maybe the benefit of modularizing code is not immediately visible, or you don't make the connection to reducing the blast radius, but modularization allows you to test smaller pieces in isolation before you put them together to bigger systems. And it's a little bit like having unit tests for your classes before you build up a bigger system. You can think about the same thing here. So you have smaller pieces of code that are easier to handle, easier to understand. Also, the amount of people that work on such a module is smaller than on the whole infrastructure. And our idea was to use what we call a modules of modules approach. So we have small modules for services that then make it up to a module that describes an environment and gets then instantiated per environment. I should have a slide in place for that. Yeah, here we go. So for those of you who are familiar with Terraform, that is the file structure we use here. So we have this modules folder here that holds the smallest modules for a service. And each team can have one or multiple services, and for each service, a team will create a new module here. So the infrastructure of such a module mainly reflects the infrastructure that is required for one service. Those modules get then aggregated by what we call an environment module. So the environment module kind of has a file for each team in which they aggregate all the services for one team. And at the end, the environment module exposes a bunch of variables that you have to provide when you want to instantiate the environment module in your environment. So since we have 4 environments, we have 4 times the same structure regarding the environment directory. It mainly consists of one main file that references the environment module. Shared is a little different, but I hope you get the idea of how this is organized. So this is a an example of a Terraform code that describes such a service. You can ignore the resource group at the top, but here we, for example, describe a container registry that holds some build support images. This is required for service A. And then in a second file that is on a team level, this service A module is referenced here, and you provide all the variables that are necessary for this service module. This should be service B, sorry, it's a typo. So you can have multiple services as a team, and you aggregate them in the team file of the environment module. And then you finally instantiate this environment module in your environment, in this case in development. So you reference the environment module here. You set the variables that are required to instantiate this template, like for example, the stage you're working in or some user IDs. And then Terraform can actually bring up or apply the changes for one environment. If you want to read more on how to structure your configuration for production, there is a nice blog post on the Hashicorp website. I have the link in the references of the slides. The next measure we agreed upon was splitting the Terraform state. I hope the introduction to Terraform made it clear that when the state gets messed up, you at least have a severe issue, if you can recover at all. So it is generally a good idea to keep the state small. And our approach was to have a separate state file per environment. So now we work with 4 different states. And if you damage your state in the development, it will not affect your production state. And also the same holds for the shared environment. The state file that you use can be referenced in the configuration for your backend. So here you can see we have separate storage containers for the state files, and we have one for development and the file in there for the state, and we have one for non-prod, one for prod, and one for shared. By the way, for those of you who know Terraform better, it's maybe worth mentioning that there exists a concept in Terraform that manages such environments for you. It's called workspaces. I heard different things about whether you should use it or not. Some people said, yeah, you should use it and it's cool. And other people say, no, it's still flaky and you don't really know what happens with the state since it's completely managed by Terraform. So we decided to go with kind of a self-implemented approach, which is not too hard. And we do not use workspaces as of now, but I think there are pros and cons to both approaches. Another measure we took was to lock stateful resources. This means, for example, when you create something that can simply be recreated and there is no data loss when you delete and recreate it, you might want to use the comfort of infrastructure as code and simply change the code and resources change. But for other resources that contain state, for example, databases, container registries, blob storage, or key vaults, and that might also contain state that is hard to recover once it is gone, we decided we want to have some fallback or some safety net that at least prevents an accidental deletion of a resource. And what we did therefore is to introduce a lock. I'm not sure, I think locks are also available for other cloud providers. I'm only familiar with Azure. So in Azure you have this concept of a lock that kind of prevents a resource from being deleted. And if you want to delete a resource, you first have to remove the lock before you can remove the resource. It's no guarantee that the resource doesn't get deleted because people can of course remove both and then it's gone. But at least I think accidental deletion is harder to happen. So that's why we decided to do this. The downside of it is that you have to change 2 things if you want to delete a resource, and that you also sometimes require at least 2 Terraform runs for the changes to be applied, because for some resources, it's not possible to delete them in one go when they had a lock before. So why did I tell you all those measures? Because we thought it's important to have this in place before we go for a full automation of our Terraform code. Maybe it's a good time to take another break and see whether there are any questions.
There's plenty of questions. I think
there's plenty of questions.
Okay.
We tried to mark which ones have not been answered totally from Tim and Mario in the chat. So maybe I can just start. What does it mean to split state? Is this an outcome of inframodularity?
Not directly. I think, imagine you can have a big Terraform script with all your resources that you provision in the development or testing environment and in the production environment. No one prevents you from doing so. And this would mean that the state of those resources goes into one big file. So if you make a change and for some reason mess up your state, this means that the state of your production resources as well as your development resources is just corrupted or broken. So splitting up the state in our case means that we have a separate state for the development environment and for the production environment. And if the state gets corrupted in development, what we use before we promote to production, it only affects development, which might have no impact on the users at all. Does this answer the question?
I hope it does.
Okay.
Okay. Where do you run Terraform code, in Azure DevOps, Azure Container, Azure Shell, or local laptop?
We started running it on our local laptop, as I mentioned before. So people cloned the repository, downloaded the Terraform binary, and then simply started to run Terraform init, Terraform apply. And now we move to running it in a build agent on Azure DevOps pipelines. So it's running on VM.
Okay. It looks like your Terraform code for many services is all in single infra repo. Was there any intentional decision to do this instead of putting the Terraform scripts alongside service code inside each service's repository? What drove that decision?
Brilliant question. I think the decision was driven by the fact that when we started refactoring this, we had everything in one big repo and wanted to keep it simple at the beginning. We now are at a point where we consider moving certain parts out in different repositories, which also makes the pipelines run faster, the impact smaller, the state smaller. So I think there are a lot of good reasons to split this up. We didn't do it at the beginning because we wanted to start simple. Some teams on our account already use separate repositories for their infrastructure. And I think their experience motivates us to also split up our monolithic repository in the near future.
Okay. What's the best place to version control infrastructure code, in repo with application code or in a separate repo? I think it was partly answered, but maybe you want to answer.
I mean, one idea to separate it is also to bring it together with your application code, which I think is generally a good idea to have this in one place. On the other hand, you might run into some issues on what triggers which pipeline. So do you always run the infrastructure pipeline before you deploy your application? Do you somehow detect whether there are changes to the infrastructure before you do this? So I think we will figure out, but I like the idea of having those two things together.
Again, to splitting. Why not to split states down to each independent service?
I think that is correlated to what I just said. We wanted to start simple. And maybe one thing worth mentioning is by gaining autonomy in one dimension, you also increase complexity and, for example, make it much harder to recreate all infrastructure because you have to orchestrate multiple pipelines in multiple repositories. So I think you have to be careful not to exchange one problem with the other. But generally, I think I learned a lot from Tim there. I would agree that splitting things into smaller parts makes it easier at the end and also reduces again the blast radius.
Mm-hmm.
And actually, so my team have currently started from the sort of opposite side of where Michael's team are. So Michael is talking about breaking up effectively a Terraform monolith. My team started a few months ago with a blank slate in AWS, and we've built lots of micro pieces of Terraform which define small, tightly bounded pieces of infrastructure. So they just define the roles in account, or they just define how we exchange, how we publish Amazon KMS keys, or they just define how we configure our node groups for Amazon's Kubernetes service. And we have split state for each one of those different pieces of Terraform. And that is a, we're now talking about how we could merge these pipelines together into a larger sort of definition of a bigger piece of infrastructure, because we have to pass a lot of information between different pieces of Terraform. It's relatively straightforward to do it with, there's various tools we can talk about in the chat later on without derailing Michael's talk.
Thanks for answering.
Thank you. Another one, what's the best place to version control infrastructure code, in repo with application code or in separate repo? We have already answered that. I just realized. Yeah. Do you use tools like Test, TerraTest, Kitchen Terraform, Validate, or some part of GOCD can help with testing?
I think we cover parts of this later on.
Okay.
So
Cool.
we can maybe postpone the question.
Yeah.
Mm-hmm. Okay. Short recap of what we talked about. We started working with Terraform in a big monolithic repository that developers checked out on their local machine, applied changes, hopefully didn't forget to commit their changes, and it was a little cumbersome. And the idea after we had this outage was to further automate this, also to prevent outages in the future and have a more familiar workflow for developers, which is mainly code, push, build, test, deploy. Another nice side effect of running Terraform in pipelines is that you can enforce staging. So since infrastructure changes might take a little more time than building a simple app, you might be tempted to just do changes in production because you don't want to wait until they made it through another stage. So running a code in a pipeline can enforce a certain staging workflow and can prevent people from doing, let's say, not so cool things. We talked about the forgotten commits. And another side effect of infrastructure pipelines is that you have a nice traceability of changes, which means you can correlate changes to your infrastructure to features or work packages you have in your sprint or in your stories. So you can directly see for which feature did I have to implement which infrastructure, when was this change applied to which stage, how long did it take for a change to make it from dev to production. So all this you can read from the metadata you get out of a pipeline. There is another nice article on the Hashicorp website that I would recommend to read if you are planning to run your Terraform in pipelines, which is running Terraform in automation. And for those of you who are as lazy as me, I created a little summary of this that I would like to present here. So the first and obvious step is disable all manual input. There are different, let's say, interactions with the user when you do a Terraform, when you run a Terraform command on your laptop and you want to disable this when you run it in a pipeline. It's an easy one. The second thing you might want to consider is you want to archive your plan. So we said that there is this step where Terraform calculates the differences between what you have in place right now and what your scripts describe. And this difference is stored in what is called a Terraform plan. And if you want to have a manual approval of this plan, you can run into some kind of race condition where the things changed in the background while you are checking the plan. And you want to make sure that only those changes get applied that you saw in the plan and that you approved. So it's generally a good idea to archive this plan and to make sure that the apply only happens to the changes in the plan. To speed things up, it's a good practice to package the whole Terraform folder that mainly contains the plugins. And I think the Terraform binary has around 60 megabytes. The plugins we use have around 250 megabytes. So if you have to download them for every stage, this can sum up to quite a severe amount of time and slow down your feedback cycle. So you might want to package this. And you also might want to make sure that you pin all the versions so that you can be sure that when you run your code with a certain version in development, you run the code with the same version of Terraform and also with the same version of the providers in the production stage. And for the actual apply, you then have to turn on the auto approval, because otherwise the Terraform apply command will stop in the middle and ask for user input that you normally can't provide in a pipeline. So this is the summary of this blog post. And then when I started to work on those pipelines, I asked my followers on Twitter on whether they run their code in pipelines, the Terraform code, and whether they do it in a gated pipeline or in a fully automated pipeline. And here you can see the outcomes. So 1/4 has no pipelines at all. Half of the people run in a gated pipeline. I come to that in a minute. And 1/4 runs it in a fully automated pipeline. I think the question is important because from my point of view, it's one of the main design decisions you have to answer for your pipelines. Do you want to run them fully automated? Do you trust whatever testing or checks you have in place and say, whenever I push something to my repository, I'm confident that this change can make it all the way through to production? Or do you say, I use the tool that Terraform provides me to have a plan and to check it before I apply the changes, and therefore stop my pipeline at a certain stage, look into it and say, yes, you can go, or no, please stop. We started with a gated approach. This means our basic pipeline looks like this. We have a build stage, a plan stage, then we stop the pipeline, ask for approval, then run an apply stage, and then a test stage. The following slides will give further details on those stages. So the build stage, of course, clones your repository, installs Terraform, thereby makes sure that the Terraform version that you configured in your code exists, initializes Terraforms for all environments at once, which makes sure that the provider exists and that the remote backend works, and then does a Terraform validate. I think that answers part of the question before. And we also run this validate for all environments right at the beginning in the build stage, because I think the validate is a few seconds. And when you wait with that until, for example, you apply your changes in production, 5 minutes can pass until you run the validate, and then you see that your code for the prod environment is syntactically incorrect, and you could have seen this after only 30 seconds. So Terraform validate checks for syntactical correctness right at the beginning. And the last step of our build stage is that we publish a Terraform package. In this case, this contains all the scripts that we wrote, so the content of our repository, the Terraform binary that we downloaded before, and the Terraform plugins and providers. And this can easily sum up to a few hundred megabytes. So this is also kind of a promotion of our infrastructure code. You might know the term promotion from application pipelines. So with each stage that you pass in the pipeline, you want to get more confidence or gain more confidence that your code will work properly in production. One example of such a Terraform validate output is that here I think we missed a variable that we used in a module, but it was not defined. So Terraform stopped before even running a plan, and we can fix this bug and got this feedback after like 30 seconds into the pipeline. I mean, of course, it's also something that developers could run on their machine before doing a push, but I think we all know each other very well. Sometimes we do it, sometimes we don't. So I think it's a good idea to do that at the very beginning of your pipeline. The second stage then is the plan stage. this stage starts with downloading the Terraform package that we created in the build stage. Therefore, we can skip any clone and also the download of providers and Terraform binary. It's included in this package. And we run a Terraform init. We need to do that because we have to get the state every time we work with Terraform. And of course, maybe it's worth mentioning that we don't want to have the state in the package because it contains sensitive data. And it's crucial that this data doesn't leak. So I don't want to have it spread around in different places and only keep it in an encrypted storage like a bucket or whatever. But therefore, we need to initialize Terraform every time we run another command. So we start with downloading, do a Terraform init, and then run a Terraform plan with the flag that it outputs the plan into a file. The last step of the plan stage is then to publish this before created package together with the now created plan and move it on to the next stage, which is the apply stage. Yeah, but maybe I can go into some details of the plan job that we ran before. There is a nice feature that I only recently discovered in Terraform, which is you can have the plan command output a detailed exit code depending on whether there are changes to the infrastructure or not. So with this detailed exit code switch, you can then go through the exit code of Terraform and see whether it's a 0, this means there are no changes, whether there's a 1, this means that the plan has failed for some reason, or whether it's a 2, which means that there have been changes noticed. And when you hide the output of Terraform during the Terraform plan command, you now get a nice overview of only the plan changes when you use the Terraform show together with the plan that was being created. This just keeps your pipeline a little cleaner and makes it easier for the pipeline operators to see what changes actually would be applied in the following stage. So maybe this snippet helps you to improve your pipeline or improve the workflow. Yeah, after the plan, we have the apply stage. As I mentioned, it's a gated stage. So we start with a manual approval before we run the stage. In Azure DevOps, this manual approval is a click in the UI, which I kind of don't like too much, but that's how they do it. There are other options to implement such an approval. For example, you can have a version file in your repository that kind of pins a certain version you want to bring into production. The downside to this is that you have to run the pipeline twice in order to make a change to production, because you first have to create the version and then have to change the version file and then rerun it. But yeah, there are different ways to implement this. You can also work with pull requests. At the end, it's your decision whether you want to have a gate or not. And if you go with a gate, you can decide what implementation you choose. So then the apply stage again starts with downloading the Terraform package, this time with the plan included. Then we do the Terraform init again. We don't have to download the plugins because they are already contained in the package. So this saves some time. And then we can run the Terraform apply with an auto approve, not to stop and ask for user input, with the plan that has been created in the previous stage. At the end, we tag the version. I think it's a good idea to see either in your repository or at least in your CI server when an environment had been changed and with what revision of your source this happened. So I think this tagging is a good idea for traceability, and you can also use these tags later on to see or to create a metric how long it takes for your changes to make it to production. The test stage as of now is rather small. The reason for this is, first of all, we didn't have too much time to dig into various test tools that have been mentioned before, like TerraTest, or I think it's called Kitchen Terraform or something like this. And also we don't have those small modules right now that would allow us to test our infrastructure code in smaller pieces. What we definitely do is we want to check that the high level functionality works as expected. And therefore we have smoke tests that we run. I just provide a little example here. So for example, when we provision a Kubernetes cluster, At the very end, we want to make sure that we can log into this cluster and that the credentials for this cluster that get stored in some vault exist and are valid and allow us to log into such a cluster. So we have tests like those in place to verify that after Terraform apply in a stage, the high-level functionality of the system works as expected. There is a very nice video that I got recommended from some colleague, which is called Test-Driven Development for Infrastructure. It's from a developer advocate from Hashicorp, the company who builds Terraform. And it has a lot more ideas on how you can test your code. We will definitely dig into that and try to implement different kinds of testing when we think it's useful. But as I mentioned, for now, our tests are rather simple. So to recap how this basic pipeline looks for us, we have the build stage that does an init and a validate, creates this package with binary and scripts. We pass this package on to the plan stage, where we again do a Terraform init and then a Terraform plan. We output the plan into a file, put it into another package, publish this, and move it on to an apply stage that has a manual approval. In the apply, we again do an init and then apply with the previously created plan, and then we move on to a test. So one thing that maybe is not clear right now, but this idea of environments now kicks in. And when we chain such a basic pipeline to provision a dev environment with a second run of the pipeline to provision the prod environment, we kind of have implicit testing by making sure the provisioning happens or works in dev, and can be more confident that it then works in prod as well. I hope this idea is kind of clear. So maybe now it's a good time for another round of questions, if there are any.
Yeah, Tim did another great job in answering a lot of them. How do you build the pipeline itself, also with Terraform?
No, we don't do that right now, but I think it's generally a good idea to do it.
Okay. How do you publish the various Terraform packages? Is it just pushing a Docker image to a registry every time?
Since
Tim also partly answered that.
Okay. In our case, we work on Azure DevOps Pipelines, and Azure DevOps Pipelines have this concept of build artifacts. Mm-hmm. So you can basically just zip your whole workspace into an archive, and then it gets automatically uploaded to kind of an artifactory, which is built into Azure DevOps. And in the next stage, you can download it from there, extract it, and go on with the pipeline. That's what we do right now.
Could you elaborate more on why the download Terraform package is needed in every stage?
Well, modern CI tools tend to have stages stateless, which means there is no automatic passing of any artifact or anything in between stages. That allows for, I would say, better scaling, and is generally a concept I like. But the downside to this is that whenever you need an outcome from one stage in a following stage, you have to take care of that yourself. So you either have to archive it and push it to the artifactory, or you have to use S3 storage or whatever. But I think the reason for that is, or the reason for that is that the stages in Azure pipelines are stateless.
Mm-hmm. What if the test stage in production fails?
Yeah, that shouldn't happen. I mean, if it fails, you at least immediately know that something went wrong. Mm-hmm. It's like your smoke test in your delivery pipeline for the application fails after you deployed the application to production. Yeah. Maybe the question is towards, do we do a rollback or something? No, we don't. And I would say that generally rolling back infrastructure is not easy, if possible at all. So we don't have any automatic workflow processes in place to roll back anything.
When automating Terraform plan, apply in a pipeline, no manual approval, do you put any restrictions on? for example, don't automatically apply if there are any destroys in the plan?
No, since we have the gated pipeline, we did not elaborate on any measures like that as of now.
Okay. Thanks for answering that. I think that have been the answers, the questions that Tim hasn't answered yet.
Cool. Tim, thanks so much. I owe you,
Great support.
I owe you a beer, at least one.
Okay, maybe we can have like one last question until you move on. Are you running the pipeline from non-master branches? If, what happens there?
When I started at ThoughtWorks, I learned that there is a very strong opinion on trunk-based development. So ever since then, I think I created 2 branches, and I hope that that answers the question. So there are no branches in our repositories.
If you come to one of my presentations, there's usually a bit about you just do everything in master.
Yeah, I forgot to mention that, but there are no branches in our repositories anymore. Yeah.
Cool, thank you, Michael. I think you can go on.
Yeah. So I talked about feedback cycles, and I just wanted to give you an impression of how long all this takes. So given we do not start from scratch because we have, for example, several Kubernetes clusters that take, I don't know, like 50 minutes to get provisioned. We usually end up with a pipeline run of about 10 minutes when we go through all the stages. And this also includes the waiting time until someone clicks the button for the gated approval. So I think it's kind of okay. I saw that Tim's smaller pipelines run in 2 minutes, and I'm super jealous. So I also would like to have that, which is also maybe a motivation to slice down things and have smaller pipelines. But I think 10 minutes for infrastructure provisioning is okay. Yeah, there is one last thing as a best practice that I want to share, because I think I also learned this the hard way when I started with this pipelines. Most CI tools that you use nowadays have their pipelines described in YAML files. And I think that's fine until the point where those YAML files get mixed with hundreds of lines of code of shell script. And that is what you usually see. And it starts with the files getting very hard to read. You also lose any form of syntax highlighting or shell checks that you want to have to catch errors early in your editor. And the recommendation I would give, or the thing that we do, is we strictly split the logic that we write in shell scripts from the declaration of the pipeline. And we use what we call a do script or a go script, which is simply a more or less longer shell script that contains all the tasks that we run within our pipelines. It has several benefits. First of all, it's a plain shell script. You can make use of all the editor features that help you to write good and error-free shell scripts. But you can also run those scripts outside of the pipeline on any machine. So when developing a pipeline from scratch, you might want to avoid long feedback cycles, make a small change, wait for 10 minutes, see there's an error, run another pipeline build, wait for another 10 minutes. So once you have this separated in shell scripts, it's just a matter of seconds to run it on your local machine and get immediate feedback on whether those scripts are correct or not. Another benefit is that you are a little less depending on a CI service provider. So since the pipeline itself only calls the shell scripts, I would say there is a looser coupling between the functionality and the CI system you're using, and it's easier to move if you want to do that. Also, I think it's a nice way to share knowledge within your team or have people quickly onboarded, because once your developers know about this concept, they will search for this script in any repository they have to work with and can quickly get onboarded with how does this build, how can I test, or how can I run tests, or yeah, all those tasks that you normally describe in a README. I think they are better put in such a script that can just get run. So this being said, I come to the end of my presentation. As a short summary, maybe you have seen that once you have infrastructure as code, in place. I think pipelines are a good next step to improve your infrastructure workflow. I hope you have seen that it's nice to provide developers a familiar workflow when it comes to developing infrastructure code. I heard this sentence of a colleague in my team that has a lot of experience as a consultant, and he said the first thing he asks himself when he comes into a new project is, how can I make myself redundant? And maybe that should be a guideline for you as an infrastructure consultant. How can I make myself redundant in terms of the developers in my team can manage the infrastructure by the tooling and the workflow I provide to them? You hopefully have seen some useful steps of how you can prepare your Terraform code before you run it in automation. You should have gotten a few ideas around how you can reduce blast radius as far as possible. And I hope you also realized that our journey into this topic did not end yet. So I think the questions you asked towards slicing down things, having separate repositories, bringing infrastructure code closer to application code, all those are things we will consider in the near future. And the basic advice I would give is go one step at a time, check and iterate on that. And don't overdo it from the beginning, because things can become very complex and can become unnecessary complex. So start small and go bigger if needed. I want to take the chance and say a big thank you to a few people who helped me along this way. First of all, Jonathan, who I think is in the call. He's working in another company I have the pleasure to work with. And I think he was a great mentor for me to get me started in Terraform and Azure. And 90% of the things I know, I learned from him. So thank you very much. Also, Tim, you had the pleasure to get to know him already. He was a super great onboarding buddy for me in ThoughtWorks, and also the father of many ideas in this presentation. So Tim, again, thank you. Then there's another guy called Ala, and he's working with me in the Stuttgart office if we are working in the office. And he was actually the only person who had the time to review the presentation before I gave it. So I'm really very thankful for all the tips that he gave me. And also the ThoughtWorks infrastructure community did a great deal on helping me with a lot of good discussions, always challenging me on my ideas and helping me to learn in this topic. So thank you all. And now it's time for a final round of questions.
Let's get another question. Okay, one question that was cut off earlier was, do you run Azure Resource Manager templates from Terraform, TerraGrunt?
I don't know what this is. Does this answer the question? Or maybe I know it and I don't know that I use it.
I think it was also not answered in the chat. So maybe somebody who knows what it refers to can just ping the question, ping the answer.
So, sorry, I can't answer this.
Yeah, no, all good. What exactly caused your complete infra outage? I don't know if it's referring to something.
The cost, I mean, the colleagues did really a great job in recovery. I think it was like 1 day and more or less, and everything was back up. So from a man day perspective, it was not a lot of costs, and we didn't have any users on our platform, so we didn't have any financial loss in this.
Okay, it was my pronunciation. So they ask for the causes.
The causes. I'm not 100% sure, but I think at the end it was a corrupted state.
Okay.
So Jonathan could probably answer this with more details, but I think manually editing the state might have been the root cause.
Okay. Cool. And how are you managing state migrations? For example, I want to rename a module.
We haven't done this yet, so I can't answer this.
Cool. Let me check if there's anything new. Okay, if we jumped over one of your questions, feel free to Ping it in the chat again. Other than that, there's some, do you have an opinion on TerraGrunt?
I stumbled over it when we wanted to have, I think it's called life cycle hooks that prevent accidental deletion. And we figured out that you cannot have variables in that. And we thought about whether TerraGrunt is a good way to have kind of a pre-processing. Actually, we didn't try it out because we didn't want to introduce another tool and more complexity. So I have no experience with it and no strong opinion.
Okay.
My team's evaluating it next week.
So there's another talk soon.
We think it will fix some of our problems because we have quite a lot of repeated variables and config for some of our basic setup. And we think TerraGrunt will solve that problem for us. But we're evaluating it next week.
We just started using TerraGrunt, and yeah, it fixes some of the repetition problems. So I think it can be useful, and it's basically a wrapper on top of Terraform, so you don't really add a lot that cannot be easily taken out. So I think it's low commitment as well.
It's effectively a preprocessor for Terraform, as I understand it.
Yeah, essentially, yeah.
Cool. Again, to Azure Resource Manager, somebody asked how you would integrate it.
I don't know.
Okay. Yeah,
but I will read it up. It seems like something you should know.
The other question, which I couldn't answer, was also an Azure one. Can you do versioning in Azure storage buckets for the state file?
I would assume, but I also don't know for sure.
Okay.
Okay. Any other questions?
Yeah.
Okay.
I collected some resources that I mentioned in the talk. It's in the slides, and the link to the slides should be in the chat. I uploaded them as a PDF to GitHub. It would be super cool to get some feedback from you on the talk, what you think about it and where I could improve, or maybe what I missed, or where you have a different opinion. So feel free to ping me anytime on Twitter or write a message in the Meetup group, or here you can also find my email address. You can always send me an email. Would be really nice to get some feedback, and I try to answer all the questions. Okay, cool. Then that's it. Thank you very much.
Thanks everyone for contributing so much. Thanks Tim, thanks Mario, thanks for everyone else who answered so many questions in the chat. I think it was probably helpful for everyone. So thanks a lot. That was a great meetup. Thank you.